So we are determining the purity of a sample of potassium iodate was determined by titration. The steps of experiments are follows. 0.1 gram of a sample was dissolved, then 100 cm cube appropriate flask, so we use volumetric flask, and then we took out 10 cm cube of potassium iodate, and then we add excess of potassium iodide, and sulfuric acid is the produced solution T containing iodine, and then T was titrated with sodium thiosulfate. Step 2, 3, 4 are repeated twice. Name a piece of apparatus which is used to remove 10 cm cube portion. So when we want to remove like fixed amount like 10 cm cube or 25 cm cube, in that case we need a pipette. So pipette is the most appropriate apparatus because it is 10.0. So 10.0 means accurately we want to remove. And pipette, like we can have different size of pipettes. Small pipettes can measure 10 and large pipettes can measure 25. Name the indicator which we use. So whenever iodine and thiosulfate titration is there, we always use starch as an indicator. And what is the color change? Whenever, so initially it is blue black, but when iodine molecule is present, and then it turn into colorless. So starch is there as an indicator. And what is the color change? It's from blue black to colorless. Then the titration results were obtained. As you can see, complete the table by calculating the titer. So how to calculate? We subtract the final minus initial will give us what is the volume. So it is 14.5, 13.7 and 13.75. So when we subtract 14.5, this will be 13.7 and this will be 13.75. Then explain why the correct value for the mean titer is 13.73. Because when we take this value 14.5, it's not not concordant to 0.1, like with not within the range. Any value which is 0.1 more or 0.1 less we can use in our calculation, but 14.5 is not concordant to 0.1, like it is more than 0.1. And normally the first result is always a range finder, like this is a rough titration or it's a range finder, so normally we ignore that. Just it is used to identify, or you can also mention it is not within the range, or the first value is not within 0.2 centimeter cube or 0.1 centimeter cube. That's why we are not including in our result. Then calculate the number of moles of sodium thiosulfate. So we have the volume and concentration, so we can find the moles of sodium thiosulfate, which is moles equal concentration into volume. So volume, the titration, the mean titer 13.73 and the concentration was 0.02. So 13.73, but that is in cm cube. We divide by 1000 to convert into dm cube, and then 0.02. So we multiply, it will be 2.74 into 10 power minus 4. That's the concentration. Then, sorry, that's the moles. Then calculate the number of moles of iodine in solution T. So how to get the number of moles? We have the moles of thiosulfate. We want the moles of iodine. So ratio is 1:2. So if we have the moles of thiosulfate 2.74 into 10 power minus 4, this will be X. So this will give us the total moles of iodine, which is 1.37 into 10 power minus 4. So using a ratio, we work out the moles of iodine. Then ionic equation for iodate is shown. Use the equation and your answer. Calculate the number of moles in which reacted to produce solution T. So now we have the moles of iodine and we need a moles of iodate. So ratio between them is 1:3. So as the ratio is 1:3, the number of moles of iodine the number of moles of iodine were 1.35 into 10 to the power minus 4. So that will be divided by 3. So because this is 1.35 into 10 to the power minus 4, this is x, so cross multiply, we'll get the moles of iodate, which is 4.58 into 10 to the power minus 5. So just you have to use a mole ratio when equations are given. Then name up appropriate flasks which we use in step 1. So we use volumetric flask. Then describe how we make 100 cm cube solution, like how we make a standard solution which is having a known concentration. So we'll transfer the solution first and the washing, and we'll make up to the mark and shake the mixture. So we'll transfer solution and the washing, like we'll wash the container and they all be transferred to volumetric flask. And then we will make up to the mark, like adding a distilled water. Or deionized water, you can also say. And then we will shake the mixture. Put stopper, one important thing is put stopper and shake the mixture. That's how we make this standard solution which we know that how many what is the concentration. Then calculate the number of iodate in 10 cm cube, 100 cm cube. So in 100 cm cube it will be 10 times, because in 10 cm cube it was 4.5 into 10 to the power minus 4. In 10 cm cube, like 4.5 into 10 to the power minus 5 but there in 10 cm cube. In 100 cm cube it will be x cross multiply, so it will be 4.5 into 10 to the power minus 4. Calculate the mass. So how to get the mass? Moles multiplied by molar mass will get the mass. And then calculate the percentage purity. How to get the percentage purity? Original mass, like the mass of the sample which we get, divided by original mass into 100. And most significant hazard in step 3. So when we are adding, because in step 3 we are adding sulfuric acid. So sulfuric acid are corrosive. As you can see in step 3, sulfuric acid is added, which is corrosive. So it can be irritant or corrosive. That's the main hazard for sulfuric acid. Here step 3, sulfuric acid is added. So this is how we work out the percentage purity of potassium iodate by using titration.